In this podcast, we're going to discuss the third gas law, Guy-Lussac's law. This law states that pressure and temperature are directly related, given volume remains constant. The equation that describes this is P1 over T1 equal P2 over T2. Now let me note that temperature should always be in Kelvin when you're dealing with this. I like to make the equation linear, just as I did with Charles's law. So I'm going to cross multiply the t's up, and I'm going to get this equation. Okay, so that's the equation I will use, the linear form. Here we can see a molecular level representation of Guy-Lussac's law. We see that we have gas particles in a box. And here's the pressure sensor and the temperature sensor. I'm going to increase the temperature by adding heat. And you see that there's a direct correlation with the pressure. The pressure goes up just as the temperature goes up. So they're directly correlated. And then if I were to decrease the pressure, which we can do by letting some of these little molecules escape real quick, we can decrease the pressure. You see that there's a direct decrease in temperature. So pressure is the collisions on the molecules. Temperature is how fast they're going. So when you make them go faster, when they're traveling faster, it would make sense that they have more collisions with themselves and the walls of the container. Therefore, the pressure also increases, okay? So keep this in mind when you're doing calculations involving Guy-Lussac's law. This is what we're really talking about.